Okay. So we have done till now continuity. We have done till now limits. So yesterday also started with continuity. I'm again going to make some background for continuity and then we'll go along. So continuity of a function. So I told you yesterday that also, and that I'm going to repeat today also, that a function is said to be continuous at a point, let's say a, if limit x tends to a, f of x is equals to f of a. Okay, so that is one thing that one needs to remember, that if, let's say my function f is defined on interval I to r. Okay, let's say my function f is defined on interval I, where I is a subset of real numbers. And let us say that there is a point called as x naught which belongs to I. Then if limit, which limit x tends to x naught, f of x exists and is equal to f of a, is equal to f of x naught here, then we'll say that f is continuous at x naught. Okay, so in any case, if a function is continuous, so if a function is continuous at a point, then it must be defined at that point. Then it must be defined at that point. Is that clear? Because if function is not defined at that point, if let's say there's a point x naught, if at that particular point my function is not defined, then my function will not be continuous. I give you several examples to illustrate this. Is that fine?
Yes.
In other words, I will write that limit x tends to x naught, f of x should be equals to what? F of x naught. So if I want to formulate an epsilon del definition, what it will be? So I will say that in function, the distance between function and its limit can be made as small as possible. So you give me an epsilon. Epsilon is what? It is a very small positive number. What does it mean? It means that fx and fx naught. What it means, that distance between the function and fx naught can be made less than epsilon whenever distance between x and x naught can be made small. That small is written as del. Okay, and here x belongs to I, interval I. So what does it mean? It means that whenever you are taking x in very close vicinity of x naught, then your function is in close vicinity of fx naught. So this is referred to as epsilon del definition of continuous function. What does it mean? It means that your distance between function and fx naught can be made as small as possible. And do you understand the inequality? What does this inequality mean? This inequality means your function lies between fx naught plus epsilon and from fx naught minus epsilon to fx naught plus epsilon. Is that clear? So it means that your function is in close neighborhood of f of x naught whenever x is in close neighborhood of x naught. So you give me an epsilon, I will give you a del. Every time you say that, okay, that is my function very close to fx naught, I will say, okay, yes, it will be close to fx naught, provided x is close to x naught with a certain degree. So if I'm in a position to say this every time that you give me an epsilon, it implies that my function is continuous. Is that clear to you? Or should I repeat it again? Harshit, should I repeat it? Mm. Okay, just give me a minute. Am I audible, Harshit?
Yes, sir. Yes, sir.
What did you get my point? What I wanted to say. So, for example,
Sir.
what I want to say that let's say my function is defined at point x naught. Okay. What does it mean? It means that whenever my function is between x naught minus del to x naught plus del, whenever your x is between x naught minus del plus x naught minus del to x naught plus del, your function is between. So in this particular range, your function is between f of x naught minus epsilon to f of x naught plus epsilon. What does it mean? It means that as close as you are going to come towards x naught, you are going to get as close as possible to fx naught. So all these things, as close and all these terminologies don't work in mathematics. You need to be quite concrete when it comes to mathematics. So what does it mean? Let's say if I say that my function, let's say I'll take a simple example. If limit x tends to 2, x square is equal to what? 4, isn't it? It implies that x square minus 4 distance can be made as small as possible. Let's say Harshit gives me epsilon equals to 10 to the power minus 2. Is that clear?
Yes, sir.
Okay. So what does it imply? It implies that I know that as x tends to 2, your x square will go towards 4. So limit x tends to 2, x square would be 4, isn't it?
Yes,
so
sir.
what does it mean? It means that function and the limit, distance of function and limit can be made as small as possible. And what is this as small as possible? This is given by epsilon. So you can take it as small as possible. So right now Harshit says, okay, I will have a faith on you, provided you tell me that my function and distance, that is the distance of function and the limit, that is 4, can it be made less than 10 to the power minus 2? Okay, this is quite close, isn't it? Function and 4 is, so I'll say, okay, I can do it. I will say it implies that x square would lie between, okay, x square will lie between 3.99 to 4.0. Is that clear?
Yes, sir.
Okay, and then I will take root over on both of the sides. So I'll take root over on both of the sides. So here, x should be less than root over 4.0. Is that clear?
Yes, sir.
Okay, and it should this is one thing. From this side I can write this, or I can write that if you want to square root of 4.01, let me do it on my calculator. So I'll get that also. I just want to explain you this thing. Okay, so epsilon del, whenever you find in books, don't get panicked by it. Epsilon del means you give me an epsilon. What is you give me an epsilon? You say that distance of function and L becomes as small as possible. तो तुम ये कहने की कोशिश कर रहे हो फंक्शन और लिमिट का डिस्टेंस क्या छोटा हो सकता है. And in the case of continuous function, the limit is equals to what? It is equal to the value of the function at that point. Okay, so you'll say क्या फंक्शन और लिमिट का डिस्टेंस छोटा हो सकता है. तो अब यहाँ पर ये वाली बात है, you cannot say छोटा हो सकता है, you cannot say as small as possible, you have to give me some epsilon. So you give me an epsilon, whatever epsilon you give, I will give you a del. And what does that del signifies? It signifies that whenever you are going to say that my function and limit can be made smaller than epsilon, I will say that x can be made, x minus x naught can be made smaller than some del. So depending upon epsilon, I can always find this del. So you give me an epsilon, I will always give you a del. So your del depends upon epsilon. And what does it mean? In simple terminology, it means that distance of function and the limit, and for the continuous functions, the limit is equal to the value of the function at that point. It can be made as small as possible whenever distance between x and x naught is also as small as possible. Like, and this as small as possible would depend upon epsilon. So epsilon is also a tolerance limit. Del is also a tolerance limit. So what does it say? It says that distance between function and fx naught can be made small, provided distance between x and x naught is small. So this distance, the smallness of this distance is given by epsilon. The smallness of this distance, which is in the argument, is given by del. So for every epsilon, if I'm in a position to give you a del, then I will say that my function is continuous. Is that clear? So I'm illustrating the same using one example. I know that limit x tends to 2x square would be equal to 4. So what does it mean? This distance of function and limit can be made as small as possible. So Harshit says, okay, I will take epsilon equal to 10 to the power minus 12. So, okay, I'll say, okay, you take epsilon equals to 10 to the power minus 12. So your x square would be lying between 3.99 to 4.0. Is that clear?
Yes, sir.
Okay, and now let me calculate this. So this is x will be lying between, will be less than 2.00249. So I'll write simply 5 here. So around, I'm rounding it off. Okay. And this is one thing. And another thing is intersection x square should also be greater than 3.99. Is that clear? X square should also be greater than 3.9. What does that mean? So I'll take a root over of this also, and I will explain you what I want to say. So it implies that x should be greater than 1.997, or I'll write 5 simply. Is that clear? Okay, what does it imply? It implies that your x must be less than 2.0025, and it should be greater than 1.9975. Is that clear? And if I want to write it in a better way, I'll write if x, I'll subtract 2 from both sides. So it is like 0.0025. And here it is again 0.0025. Is that clear? What does it mean? It will be negative here. So what does it mean? Your x minus 2 ka mod can be made less than 0.0025. Is that clear?
Yes, sir.
So you have given me an epsilon. So you say that, okay, so I'll put this conversation in this way. Sudeep says that limit x tends to 2, x square is 4. So Harshit says, okay, I will have a faith on you, provided you tell me that the distance of x square and 4 is small. So I'll say how much small. So Harshit says, okay, I will believe on you, provided you somehow prove that distance of x square and 4 can be made less than 10 to the power minus 2. So I told, yes, I can make it less than 10 to the power minus 2, provided distance between x and 2 is less than 0.0025. So for your given epsilon, I am in a position to give you back a del. And this particular process, if it is true for every arbitrary epsilon, that is for every arbitrary epsilon, if I'm in a position to give you a del, what does it imply? It implies that function is sufficiently close to its limit, provided I'm sufficiently close to the argument where I'm trying to find the limit. So for example, if I'm saying x0, so you say that function and distance of function and the limit is arbitrary, is as close as possible. So I'll say yes, it is as close as possible, provided distance between x and x0 is less than something. So for your given epsilon, if I'm always in a position to give you a del, that implies that I'm in a limiting process. Or in here, I would say that limit x tends to x0, fx is equal to L. And in particular, when I'm talking of continuous function, this L is equal to f of x naught. Is that clear or not clear?
Yes, clear, sir.
This is called as epsilon del definition of continuity. So when we were doing limits, so I wrote fx minus L, but in particular in continuous function, the limit of function at x naught is equal to the value of function at that. So instead of L, I'm writing f of x. Is that clear?
Yes.
Okay. So a few things that you should remember. One of the things is that polynomial function is continuous on R. This I'm not going to prove, this I'm writing. Polynomial function is continuous on R. It's a continuous function on R. Similarly, sine function is continuous on R. Cosine function is continuous on R. Exponential function is continuous on R. So all these functions are continuous on R. Is that clear? Okay. In fact, you will find that logarithmic function is also continuous, but not on R, rather on its domain, that is continuous function on all x greater than 0. Is that clear? Okay.
Yes,
and yesterday we were doing one function in which we were doing, I think we were trying to find the points of continuity. Another function that I told you yesterday was called as signum function. So what is signum function? It is equals to modulus of x divided by x. And what does it return? It returns you the value. Let's say if it is 1, it implies you're talking about a positive number. If it is -1, it implies you're talking of a negative number. And at x equal to 0, since it is not defined, we define it some value. So exactly not mod x equal to x, but at x equal to 0, since this function is not defined, we say that, let's say it is equal to 0. At x equal to 0, it is not defined. Okay, so you can clearly see that at x equal to 0, to the right hand side, your function is 1, and to the left hand side, function is -1. So clearly at x equal to 0, your function is discontinuous. Is that clear?
Yes.
Okay. Okay. Another thing that we did yesterday was called as algebra of continuous function. Because all these things we did in a hurry, that's why I'm doing it all over again. So algebra of continuous function, what does it mean? Suppose f and g are two functions which are defined on interval I, and they are continuous. They are continuous on point x0 belongs to I. Then I can say then f plus g, k times f, in fact f into g, and f divided by g, provided g is not equal to 0 for all x belongs to I, are all continuous functions. Is that clear?
Yes, sir.
Okay. And if you know what is composition, then I'll write this also, that let's say if suppose all of them are writing without proof only. So don't worry about proof, just write it. So if function is defined from I to R, and it is continuous at, let's say at x0 belongs to I, and g is defined from, let's say, an interval j to R, and I will write and is also continuous. G is also continuous at x0. x0 नहीं, ऐसा मान लेते हैं g is continuous at y0, where y0 is defined at f of x0. Because you know when you are composing, I'll tell you what I want to say, where j is such an interval, in which range of I can be range of I can fit in. So I'll explain you what do I mean by this. Then g of f from I to R is also continuous. So what does it mean? See, whenever you compose a function, so what do you mean by composition? So let's say if I'm saying f of g of f of x. So here the range of f should be at least contained in the domain of g. Is that clear? Because see, if the range of f is such that it is not contained in the domain of g, then the function will not be defined. Then the composition of function is not defined. Is that clear? So your range of f is fi, that is for all values of I, whatever values I get on keeping all the values of the interval I, whatever values I obtain, that will give me the range, isn't it? See, for all x belongs to I, whatever are the values of f of x, this will constitute the range of f. Is that clear?
Yes.
And this range of f must fit in inside the domain of G. So therefore, this statement is here that f of I must be a subset of G. J is what? J is the domain set of G. So your range set of f must be a subset of J. Only then you can define a composition. So this is, I think, you should know that why it is written. Now it is saying that if my function f is continuous at x0 and such that your f of x0 is y0, then g of f of x0 will also be continuous, provided the composition is well defined. And for composition to be well defined, your range of f must be subset of must be contained in the domain of G. Is that clear? Is that clear? Should I move ahead?
Yes, sir.
Okay. Okay. So now we'll do some questions and then we'll move further. अच्छा, एक और चीज लिख लेते हैं, 2-3 छोटी-छोटी चीजें और समझ लेते हैं. there is something called as Lipschitz function. I don't know if it was taught to you by the same name, but you should remember this. So a function f satisfying this property, satisfying f of x minus f of I ka mod is less than equal to k times mod of x minus y for all x, y defined for all x, y belongs to I. So if function is defined on an interval I to R, and fx minus fy ka mod is less than equal to k modulus of x minus y, where k is some positive constant, such functions are called as Lipschitz functions. Okay, so such function f of x are called as Lipschitz function. Do you understand this? This is something that you have to remember. This is called as Lipschitz function. Is that clear? Is that clear?
Yes, sir.
This is definition. Okay. Now I'm writing that all Lipschitz functions, Lipschitz function is always continuous. Is always continuous. Let us see how. So see this particular definition. So what I'm doing, if a function is Lipschitz, what does it mean? It means that if I pick my x and y from some interval I, then, and if I subtract these two and take a modulus, this would be less than equal to some k modulus of x minus y, isn't it? So if I take x and y from interval I, okay, and these are any arbitrary elements. These are any arbitrary elements when you say numbers. Yeah, you can say real numbers or points or whatever thing that feels you correct. So these are any arbitrary points. Okay. So if you take any arbitrary numbers x and y from interval I, and fx minus fy you want to do, if fx minus fy you want to do and take a modulus, then it is always less than equal to k times mod of x minus y. Such functions are called as Lipschitz function. And now I'm saying that such Lipschitz function are always continuous. Okay. So how would I do it? So here it is. So let us take, it is true for every arbitrary number which is in I. So let's say this is your interval I. I'm taking x from here, and let's say I'm taking y from here. So it is true for any xy belongs to I. Yes or no? It is true for any xy belongs to I. So if it is true for any xy belongs to I, can I not take y is equal to x plus h? And h is sufficiently small. So obviously this being sufficiently small, this will lie inside I. Is that clear?
Yes.
I'm saying that I'm taking y to be sufficiently close to x such that it lies inside inside IMT. So what does it mean? It implies x will remain as it is. It will come as f of x plus h mod is less than equal to k times mod of x minus x plus h. Okay. And this all I'm writing when I'm writing that my limit h tends to 0. Is that clear?
Yes, sir.
Is that clear or
हाँ sir.
Okay. And this I'll again modify also, but right now understand this. What does it mean? It means that this will get cancelled, and this is like k times modulus of h, and here it is f of x minus f of x plus h, and I am writing limit h tends to 0 here. Okay. Now you see h tends to 0, so your mod h will also tend to 0. So this will be less than equal to 0, because as h tends to 0, this will be 0 only here. K into 0 is, are you getting my point? As h tends to 0, your right hand side will be less than equal to 0. And your left hand side, I'm writing limit h tends to 0, f of x minus f of x plus h. A mod is less than equal to 0. Is that clear?
Yes, sir.
Now let me know, can it be possible that a modulus quantity is less than 0?
No, sir.
No. It implies that your modulus quantity will be equal to 0. That implies limit h tends to 0, f of x minus f of x plus h should be equal to what? It should be equal to 0. And what does it
Yes,
imply?
sir.
It implies limit h tends to 0, f of x plus h is equal to f of x, where x is any arbitrary number or any arbitrary point in interval I. Is that clear? Arbitrary समझते हो ना, कोई भी ऐच्छिक
Yes, sir.
बोले तो ऐच्छिक, हिंदी में
हाँ
बोले
हाँ
तो
सर.
ऐच्छिक. ऐच्छिक मतलब कोई भी, इच्छा अनुसार. ठीक है. And similarly, if I want to do the same step for y is equal to x minus h, what I will get? I will get that limit h tends to 0, f of x minus h is equal to f of x. This is what I'll get. So both of these, if I summarize, what I'll get, that for this Lipschitz function, which satisfies the property that modulus of fx minus fy is less than equal to k modulus of x minus y, here limit f of x plus h you want to take limit h tends to 0, f of x minus h, all of these things are equals to f of x for all x belongs to I, because it is true for any arbitrary x, so I'm writing it for all x belongs to I. What does it mean? It implies that your function f is continuous on I. So for exam, you have to remember this, that if your examiner gives you certain pattern like this, you don't have to get confused. You have to remember that this is true for all x belongs. If this is the case, then the function fx is continuous for all x. Is that clear? मतलब अगर तुम्हें इस तरह का pattern देके question पूछे, then don't worry. Let's say somebody asks you that if f is defined from I to R such that fx minus fy mod is less than equal to 39 mod of x minus y. Is f continuous? Yes, f would be continuous. Is that clear or not clear?
It's clear, sir.
Okay, good. Okay, so these are some of the things that you should remember. A few more things I'm going to write, and then we'll move on to questions. Okay, there is yet another property. I'm not going to, again, I'm saying that I'm not going to derive it, but okay, there's a power cut. So am I audible? Harshit, am I audible?
Yes.
Okay, because the internet has somehow cut because of the this thing. So just give me a minute. So I'll do something.
Yes.
Okay. Okay. So what we were doing continuity of a function, and now I'm going to write a few things that are very important for your exam without proof. Okay. One of those things would be to say, okay, now if you have a real value function, okay, and this is sometimes when you are going to study in greater detail later on, you'll study it under heading called as extreme value theorem. Right now I'm just giving you a statement, so just I'll write important points you should remember, important points you should remember for continuous functions. Okay, the first point that comes to my mind is that let's say f is a continuous real valued function. Let us say that my f is a continuous real valued function. F is a continuous real valued function defined on a closed interval, defined on a closed and bounded interval. So let's say this is your interval a comma b. Okay. Okay.
Yes, sir.
If it is the case, then f is always a bounded function. Always remember that. Okay. what does it mean? It means that if I'm giving in the domain a closed and a bounded interval, then f is also bounded, means f will attain, I will write f will attain maxima and minima. Is that clear? What does it mean? It means that if I'm saying that my x belongs to a comma b, and if my f is continuous, and if my f is continuous, then f of x will lie between f of x1 and f of x2. And this f of x1 and f of x2 will also, like these x1 and x2 will come from this only. So what does it mean? It means your function will attain minimum as well as maximum at some point which is in between, or probably even at endpoints it will come. But overall, understand from interval you will always find that your function will attain a minimum and will also attain a maximum. Let us take some example, and I'll make you understand with the example. So let us first take the example for monotone functions. So let us take a few examples. Let's say I'm writing f of x is equal to x. I'm explaining you by example, but whenever I teach mathematics, I'll like right now you are in standard 12, so I'm not going very rigorous. But when you'll come later on in mathematics, I will on the very first day tell you that for example is not a proof. Okay, for example is not a proof. So generally we write a proof for it, but right now I'm giving you just it as a statement because you are preparing for your exam. So right now just understand using some example. So let's say if I'm saying your f of x is x, this is a continuous function. I already told you that a polynomial function is a continuous function. Now, if I say that let's say if my domain of f is given by 0, 1, let's say my x belongs to 0, 1. It implies your f of x will also belong to 0, 1 only, because your f of x is equal to x only, no? Is that clear?
Yes, sir.
Let us take another example. Let us take f of x equal to x squared. And now I'll take x lying between -2 and +2. So this is a closed bounded interval, isn't it? So your domain of f is a closed and a bounded interval. Isn't it? So your function will lie between what? It will lie between 0 and 4. That is completely understandable.
Yes, sir.
So your function has attained a maximum at 2, and function has attained a minimum at 0, somewhere between this thing. Function will attain a minimum. So function has attained maximum and minimum, and it is included. Like, are you getting my points? Your function will have these values in this particular interval. So your function is again a bounded function. Can you see that?
Yes.
Okay. So this is how you should remember. Okay. This particular theorem. Is that clear? So
Yes.
now you just give me an answer. There exists. So whenever I write this, it means there exists. Okay. There exists a continuous function. F 0, 1 onto 0, 1. True or false? There exists a continuous function f defined from closed interval 0, 1 onto 0, 1. You understand what is onto function? Harshit, do you understand what is an onto function?
So then you repeat what you're saying.
Okay. Just give me a minute. I think
Yeah.
it has come somewhere. Okay. So these are some difficult stuff that I'm teaching you right now because I want you to be on the top of the game. So this is what I want. So just let me take some minute and I'll share the screen. So this is what I was referring to. Now I was referring to that. What do you think? Do you think that here, if I'm saying, does there exist a continuous function f from closed interval 0, 1 onto open interval 0, 1? True or false? This statement is true or false? do you know what is the meaning of onto? Onto means in a very that is your range must be an improper subset of codomain, or your range must be equal to your codomain. Is that clear? So for onto function, your range must be equal to your codomain. Let's say if I write f is defined from r to minus 1 comma 1, f of x equal to sine of x. This will be an onto function because the range of function is equal to the codomain of the function. So such functions are called as onto functions. Is that clear? Now I'm asking,
Yes.
does there exist a continuous function f from closed interval 0 comma 1 onto open interval 0 comma? So I'll come to this. So this is a continuous function. I'm writing continuous function. So if continuous function, I'm writing if f is continuous, if continuous function f is defined on if it is defined on what? If it is defined on closed interval 0 comma 1, this is what? Closed and bounded. This is
Yes.
closed and bounded interval. Then the range of f, must also be closed and bounded. Closed and bounded interval, isn't it?
Yes.
But here you see, and if it is onto, and if f is onto, then your range must be equal to your codomain. That is, your range must be equal to 0 comma 1. What is 0 comma 1? This is open. This is open. See, your codomain is open, isn't it? 0 comma 1.
Yes.
So what I was telling you, that if my function, if f is continuous and it is defined on closed bounded interval, then the range of f must also be closed and bounded interval. And if I'm saying that
Yes.
if there exists a function f from f defined from closed interval 0 comma 1 onto this, that it implies that your range must be equal to codomain. If I'm saying that if at all such function exists, what I'm doing, I'm assuming that let us consider that such function exists. Let us consider that such function exists. So if such function exists, such continuous function, if it exists, then the range of that particular function must be closed and bounded interval. And if the range of the function is a closed and a bounded interval, what is this? This is open interval. So here
Yes.
you arrive at a contradiction. So therefore, there does not exist any such continuous function. So answer is false. Because
Okay.
if at all my function is continuous and it is defined in closed and bounded interval, then the range must be what? Closed and bounded. And here it is given onto. Onto means what? The range must be equal to codomain. So here you arrive at a contradiction. So therefore, always remember that if your function f is continuous and if it is defined on a closed and bounded interval, then it will always attain maxima and minima, or f must be a bounded function. Is that clear?
Yes.
So we'll meet in the next session. I mean, this is all I have to say. Then we'll do a few more things in the next session.